The massive constellation Pegasus bears the name of the snow-white winged horse born from the blood of the slain Medusa Gorgon. Riding him, the ancient hero Bellerophon soared into the sky and destroyed the terrifying fire-breathing Chimera. But today Pegasus is famous for something else. It is here that astronomers found the first planet outside the solar system. And hidden here is the Einstein cross, an optical mirage proving the general theory of relativity.
When we look up into the cosmos, we're not just seeing points of light. We're looking at a grand chart of the universe, a map that connects ancient human stories to the very laws of physics. Today, we're going to examine one specific region of that map, the constellation Pegasus. We'll treat it as a guide, from its mythological origins all the way to a stunning confirmation of Einstein's general theory of relativity.
So we'll proceed with a structured analysis. First, we'll cover the astrometry and architecture, basically the constellation's size, shape, and location on the celestial sphere. Then, we'll move on to key astrophysical objects within its boundaries. From there, we'll explore how gravity itself can act as a lens. And finally, we'll see how the myth reflects our long-standing fascination with the cosmos.
All right, let's begin with the fundamentals. Just how much of the sky does Pegasus actually occupy?
Pegasus is, simply put, enormous. It covers just over 1,100 square degrees of the sky, making it the seventh largest of all 88 constellations. Now, to put that into perspective, your closed fist held at arm's length covers about 10 square degrees. So you could tile your fist across the sky over 100 times and still not completely cover the area of Pegasus. It's a vast celestial canvas. And one of the best things about this constellation is its near-global visibility. For most of the planet, from the high northern latitudes all the way down to 60 degrees south, you can see the entire constellation. Even further south, you can still catch part of it. The prime time for observation is in the autumn months, from about August through October, when it's high in the sky.
Now, before we identify its main feature, we need to clarify a key term: asterism. An asterism is simply a recognizable pattern of stars. It's not an official constellation itself, but it's often the most familiar part of a constellation. Think of the Big Dipper. That's an asterism within the constellation Ursa Major. This distinction is crucial for navigating Pegasus.
And the most prominent asterism within Pegasus is, without a doubt, the Great Square. This huge, nearly perfect square formed by 4 bright stars is an unmistakable landmark in the autumn sky. It serves as our primary reference point for exploring everything else the constellation has to offer.
So the square consists of 3 stars from Pegasus: Markab, Scheat, and Algenib. But here's a fascinating bit of astronomical history. The 4th star, Alpheratz, isn't technically part of Pegasus anymore. For centuries, it was designated Delta Pegasi. But in 1928, the International Astronomical Union officially redrew the constellation boundaries, and Alpheratz was formally assigned to its neighbor, Andromeda. This leaves Pegasus with a peculiar absence, a constellation without a star designated Delta. Now, while the square is its most famous feature, the brightest star in Pegasus is actually Enif, or Epsilon Pegasi. And what's crucial here is understanding its scale. Enif is an orange supergiant in a late stage of its stellar evolution. Our Sun, by contrast, is a main-sequence yellow dwarf. If you were to replace our Sun with Enif, its surface would swallow Mercury and extend well beyond the orbit of Venus. It's an incredible visual of what awaits stars far more massive than our own.
All right, now that we have our bearings on the celestial sphere, let's venture deeper. We're going to move from the overall architecture to the specific, profound objects contained within Pegasus. Objects that have fundamentally altered our understanding of the universe.
This was a watershed moment in modern astronomy. In 1995, astronomers confirmed the existence of a planet orbiting the star 51 Pegasi. Now, this wasn't just any planet. It was the first exoplanet ever discovered orbiting a star like our own Sun. This hot Jupiter, as it came to be known, completely revolutionized the field. It was the definitive proof that planetary systems are not unique to us, opening the floodgates to the thousands of exoplanets we know of today.
Elsewhere in Pegasus, we find Messier 15. This is a globular cluster, one of the oldest, most densely packed swarms of stars in our galaxy. What makes M15 so remarkable is that it has undergone what's called core collapse. Imagine hundreds of thousands of stars all orbiting a common center for billions of years. Over time, the heavier stars sink toward the middle, creating a stellar density that is almost unimaginable. The gravitational pull becomes so intense that the core effectively caves in on itself. And this extreme density presents a profound astrophysical puzzle. The concentration of mass at the very heart of M15 is too great to be explained by visible stars alone. So, what is it? What could be powerful enough to anchor this crushing stellar core?
Well, the leading hypothesis is an intermediate mass black hole. This is a truly enigmatic class of object, far more massive than a black hole formed from a single star, yet much smaller than the supermassive black holes found at the centers of galaxies. And incredibly, in the same patch of sky, we also find VLAJ 2130+12, a stellar mass black hole that is currently dormant or quiet. This gives us a rare opportunity to study what these objects are like when they aren't actively consuming matter.
And then there's Stephan's quintet. This is a truly spectacular visual. It's a compact group of 5 galaxies, 4 of which are locked in an intricate gravitational dance. We are witnessing, in real time, the process of galactic evolution. We can see tidal tails of stars and gas being stripped away as these galaxies pull and distort one another in a slow-motion collision that will, over millions of years, result in their merger into a single massive galaxy.
Now we arrive at what is arguably the most profound physical phenomenon visible in Pegasus. This isn't just another object to observe. It is a direct visual confirmation of one of the cornerstones of modern physics.
The object known as the Einstein cross is nothing less than observable proof of general relativity. It demonstrates, in the most literal way, that gravity is not a force in the classical sense. Instead, it is a curvature of spacetime itself, caused by mass. And this warped spacetime dictates how everything, including light, must travel.
So how does this work? Imagine spacetime as a flat, stretched rubber sheet. Now, place a very heavy object, like a bowling ball, in the center. The sheet warps and curves around the mass. That bowling ball is a massive galaxy that sits directly between us and a much more distant object, in this case, a quasar. Light from the quasar travels toward us, but as it passes the galaxy, it has to follow the curves in spacetime created by the galaxy's mass. From our vantage point on Earth, the light appears to arrive from 4 different directions, creating 4 distinct images of the same single quasar, arranged in a near-perfect cross. It's called gravitational lensing.
So, having examined the constellation through the lens of astrophysics, let's now return to the human scale and consider the powerful narrative that we've projected onto these same stars for thousands of years.
The story of Pegasus is a full mythological drama. It begins with a fantastical birth, springing from the neck of the slain Gorgon Medusa. He's a symbol of inspiration, striking the earth with his hoof to create the Hippocrene spring, the source of poetry. He's the companion of a hero, aiding Bellerophon in his impossible task of slaying the Chimera. But the myth also serves as a cautionary tale of hubris. When Bellerophon arrogantly tries to fly to Mount Olympus, he is cast down, while Pegasus alone completes the journey, granted immortality and a place serving Zeus among the stars.
And this is really the core idea. The constellation Pegasus serves as a bridge. It connects the ancient human need for storytelling, for myths of heroes and gods, with our modern scientific quest to understand the cosmos through principles like general relativity and quantum mechanics. It's the same patch of sky, viewed through 2 very different, yet equally human, lenses.
This leaves us with a final provocative thought. The Einstein cross provided stunning visual proof for a theory penned decades earlier. Looking out into these cosmic laboratories, into places like Pegasus, one has to wonder, what other fundamental truths about our universe are already traveling toward us, encoded in ancient light, just waiting for us to develop the instruments and the insight to finally see them?
Thank you, friends. Strive for understanding and become wiser. See you soon.